more episodes of big heat in the future. And what heat represents at any time of year, a warmer atmosphere is a greater tax on water resources, both in surface water, meaning creeks, streams, reservoirs, lakes, and in groundwater through plant processes. So what this shows, this graphic, in red you can see the how green it was during 2012 drought from March on the left through the summer on the right. And the blue line is just the average. And you can see that the red line jumps out ahead of the blue line early in the graphic, and that showed a real green up during our incredibly warm March in the Midwest. And then we saw a real brown down. We saw less green in the Midwest. This is being viewed from satellite from above. And that is emblematic, if it's not driven by climate change, it's emblematic of some of the processes and changes and stresses that we expect to see more of in a changing world. And that is that an earlier warm season brings plants out of dormancy earlier. Green plants use a lot more water than dormant plants. So we started this cycle, this dry down cycle. There were plenty of factors besides climate change that contributed to the drought of 2012. But this early heat and this persistent heat was emblematic of climate change's effect on how drought can evolve. The next slide simply shows that despite the fact that the Great Lakes basin, where the water falls that flows into the Great Lakes, is getting wetter, it's also getting warmer. So kind of ironically, as precip goes up and temperature has gone up, the lakes, particularly the western Great Lakes, have gone down. And that has to do, again, with the additional tax of big heat. A warmer atmosphere can ask for more water. A warmer atmosphere can hold more water. And this combination of recent heat and relative dryness, relative to recent history, has helped draw down many of the western Great Lakes. And then just a final thought, drought is rarely, at least today, as catastrophic as the imagery that we've seen from the Dust Bowl era in the 1930s. And that's not to diminish what was going on there. I mean, that left a scar in our state that's still there. I mean, it's still a formative event from our 20th century. But we don't see these kind of impacts anymore. And I think we alluded to that in the earlier video. Management has really improved, and agriculture, water management, natural resources management has really improved. So drought doesn't look like this so much anymore, but it is very costly. Drought, because it's a supply and demand issue, if you think about it that way, as supply goes down and demand, both from an increasing population and from a thirstier atmosphere, as those demands go up, that makes the commodity more expensive. So water is going to become, and is in times of drought, more costly to find, more costly to move, and just in generally more costly. And then lastly, when you're trying to cover drought, and you're trying to even characterize drought, even as a scientist, it's not the most compelling thing visually. It's not so visible. We don't have sand drifts covering, homes like we saw in the 1930s. There's no kind of hyper weather media apparatus to draw attention to it. It honestly probably can't keep viewers and readers attracted to the concept 24/7 like scary weather can. But it is, again, it is water. It's one of the one things that holds our species together, keeps us alive. So in comparing violent weather, which we can see and understand, and we can say this is where it happened, and this is when it began, and this is when it ended. We prepare for violent weather by building structure. We tend to protect ourselves from violent weather by building things, by building structure. When we prepare for drought, we do it by building a plan. We prepare on paper. It's not about fortified concrete and digging holes in the ground and making basements. It's about communities coming together to better understand where our water comes from and what we do with it. And do we really need all of this? So violent weather tests our structures drought tests the fabric of our communities, and I've seen it over and over and over again. Towns that typically have successful programs elsewhere also have a successful water management plan. The debris of drought, violent weather leaves trees and things strewn about. The debris of drought is also paper. It's broken agreements. So instead of broken buildings and structures, it's broken agreements, meaning lawsuits about water rights, bankruptcies because people didn't have the water to do their business or grow their crops, foreclosures, etc. That's the debris of drought. That's the debris trail of drought. And then finally, one thing I've noticed is the kind of resolution to many of the severe and violent weather events that we see and experience is somebody, either a town or city official or a private homeowner say, we'll rebuild. And we all kind of collectively pat them on the back and say, go for it, good job. That's a resilient person or community. The drought resolution, the will rebuild piece of drought is long term, and it has to do with planning and education. The Grapes of Wrath was written about the Dust Bowl in the 1930s and all of the conditions and the drought that surrounded that. And there were no huge novels that characterized the big droughts of the 1950s. And that is the resolution. That the lessons learned in the 30s, the sons and daughters of the people that experienced the Great Dust Bowl and all the calamities that surrounded that led to better management practices, led to better awareness, led to better just good old-fashioned business decisions, and all of these relate to our water resources. That is the resolution piece. So instead of rebuild, they really retooled themselves as a community. Drought is such a communal experience. The problems are communal, the stresses are communal, the solutions are communal. And I think we can look to what was learned from the 30s to the 50s to see that process at work. And there's a really rich opportunity to learn from that experience. And with that, I think my time is up, and I thank you for the opportunity.
Okay. Well, very good. Well, thank you. It's a pleasure to be here and to talk a little bit about water and climate variability. And following Deke and Gary McManus, I think is appropriate because they're the scientists that put the data together. What my area of interest is in water resources, and the profession takes that information and then plans the infrastructure to supply water and to supply water during a drought or any other part of the year. So next slide. So the charge was if a severe drought situation across the Midwest continued, and also in Oklahoma, what types of solutions should be considered to address the water as a sustainable resource. And so, continued drought, what course of action? Well, if we look just back in December, we had a map, the U.S. Seasonal Drought Outlook showed a large area of persistent drought, shown here in brown, across the Midwest and West. Next. And just downloaded this yesterday, and starting March through May, you can see it's lessened somewhat. So now we still have a large area of persistence, but in this area, in the upper Midwest and western Great Lakes, it's diminished somewhat. Well, things change, and so next slide. And so we can look at stream flow and in relation to the drought. So 1 year ago, the drought was very severe in West Texas. So next. Then this year, it's expanded throughout the Midwest. So if we look at stream flow, next slide. In Oklahoma, you would have checked the same map from the United States Geological Survey just last year. You would have seen below normal almost throughout the state. But you see the green and the yellow dots to say there's actually some above normal, actually quite a few above normal. That's for this time of year. Now, what remains to be seen will be what happens when the summer temperatures increase and runoff decreases. And this is typically our wet period. So the question from a climate standpoint is, well, what will each weather system bring? Will it bring a net increase or a decrease in the stream flow? The stream flow integrates all of the various factors, the precipitation, the evaporation, the soil conditions, vegetation, and so forth. So there has been some state planning going on. The Oklahoma Water Resources Board, if you hit the next slide, finalized their comprehensive water plan just in 2012. And the goals were, of course, to characterize the demand, identify supplies, and perform some technical studies and engage stakeholders in that. And so where can we get water? Well, here's a map of the streams in Oklahoma. You can see some blue lines and some areas that are a little darker. Those are the reservoirs. And so that's the existing surface water resources. So we can take water from streams if there's a sustainable or a reliable enough source. We can also take water from reservoirs. Of course, streams can dry up, and reservoirs can dry up too. This map shows some aquifers. This is the groundwater across the state. It's not evenly distributed. A lot of it is just along streams or the major rivers, and there's a few usable aquifers, notably the Ogallala aquifer that's in the western panhandle. Panhandle, Texas actually extends all the way north to Wyoming. But the next slide. In looking at water supply sources in the year 2060, and the study is quite interesting, is that they said, well, where will the water come from? And so the darker areas you see are projected from groundwater, and the lighter colored areas are from surface water. And so where in the state can we expect to get our major water supply in the year 2060? The basic problem, I guess I want to get across, though, is that this is water in streams, and this is an annual cycle. So this is our spring season. This is the summer season. So we're above normal in the spring. We're below normal in the summer. In the summer, this is for irrigation and agriculture. We have the most demand, and also urban demand increases during the summer too. And so there's a basic problem of distribution in space and time. That is, when the rainfall occurs in the spring, we need to save it for summertime, or if we have a wet year, we need to save it for the dry years. Next. So in anticipation of that, the Water Board actually looked at a number of locations for future reservoirs, either Category 4 and 3, or 3 and 4. That just means that these have few limitations. These could be built. And so you can see there's about 68 viable reservoirs, all the little diamond symbols there across the state. These could be built, and I'm proposing that that's one solution to solving the drought problem. It's a longer-term solution because it takes a long time to put these reservoirs into place to do the planning and design studies. So Lake Thunderbird, it's located up here near Oklahoma City. You can see this blue area here. Norman is right next to it. This is our water supply. So more than likely, this is where this water came from, was Lake Thunderbird. Earlier last year sometime, the water ran off from the streets of Norman into the lake. That gives you some idea of the cycle that we're dealing with locally. And then there's a pipeline from southeast Oklahoma. There's 2 reservoirs here. This is our wet area in terms of runoff. And it's shipped via pipeline up to Lake Stanley Draper, and then Oklahoma City can distribute it to their water system. And we can also buy water when we run out in the summertime here in Norman. So we could, through Lake Thunderbird, the district that operates the lake can actually have the Oklahoma City open a tap to the pipeline, so to speak, and buy some water temporarily. Next. So it provides, this lake provides water for Norman primarily. It was completed in 1964. And I want to get to the next slide here. This is the rainfall variability courtesy of the Oklahoma Climate Survey, going back to the 1900s. So these are decadal kinds of behaviors. So next. And we're right here at about 26 inches for the year in 2012. And so the question is how variable is the climate? Well, you can also see that historically it's been quite variable too. Each one of these dots represents the annual rainfall. So climate variability is nothing new. Now climate change may be new. And one thing I think the climate change debate has done is raise the public's awareness. There is a climate, and it is variable. And so trying to predict the future is a very difficult task, but we can always look backwards. So this is going back to 1926. The Bureau of Reclamation built Lake Thunderbird, and they do these studies. And what you see here is lake level. So the blue area is lake level. The red is spilled water due to flood releases or just excess water. So we have a little bit of water that we spill from time to time. And that's, you can see in this period, this is when the dam was actually built. So you might ask, well, how do I know the lake level before it was built? Well, that's the beauty of a computer model. We can set up a system and we can model that. And you can see periods where the lake actually decreased. This is actually the drought of record in 1957. And the hope is in planning these reservoirs is if the lake was full at the beginning of the drought of record, the most severe one, would you be able to have enough water to make it through that drought? And you see in 1957 it's quite severe. And other periods too. And so back in the 20s and 30s, this is the Dust Bowl area here. And so current time is right here. So we're right here. We have kind of a precipitous drop. It's not the worst that we've had. We've had probably the lowest level back here in the 70s. So there are some periods that equal that. And what you see this decrease here, you shouldn't be concerned about that. So what does that represent? That represents if we took the drought of 2011 and 2012 and projected that forward, we just had the same weather. That is the climate change, and it's exactly like it's been the last 2 years. You see the lake is basically going dry. There's a spring season, a little bit of runoff to tease you to think that you're going to come out of the drought. But then the net effect is that over time it will dry out. Now, there were two significant events in 2011 and 2012, so go to the next slide. And if we take those two significant events out and still have the climate of 2011 and 2012, 2011 and 2012, you see it decreases and will be dry in about 2 years or 3 years in 2016. So basically, our reservoir will be just a mud puddle. So that would be the effect of having the continuation of the drought of the last 2 years in central Oklahoma on that water supply. Next. So what can we do? Well, we can increase supply. We can build more water supply reservoirs and pipelines to try to solve the time and space distribution. We can drill more wells, maybe develop more marginal aquifers, marginal meaning maybe lesser water quality, but with some treatment that could be used. And then water reuse. This is recycling of wastewater and is done throughout the country, particularly in the arid areas. We can try to decrease demand. It won't solve your problems, but it will help water conservation, reduce losses where you can, promote xeriscaping or low-impact development. And lastly, I'd say improve our knowledge and management through better science and technology and engineering for water, high-resolution analysis of water processes, advanced hydrologic modeling, and detailed rainfall and evaporation measurement. And so all of that together helps us devise better management strategies because we know where and when the runoff will or has happened, and then we can develop appropriate management strategies to handle that. I think I'll leave it right there. Thank you.
Yes, please. I think you've heard the science and the engineering, so now it's to tell you the story and to take the language of science and English and put it into something that everyone else can understand. And that's what a good reporter will do. So let's, before we do just a couple baselines here, last month that it was cooler than normal worldwide was in February 1985. For students here who were informed. So if you wanted to do the math, see how likely that would be. If you flipped a coin, because that if you look at this, That's 336 months in a row of warmer than normal temperatures. You flip a coin, the odds of that happen, let's say you get a head 336 times in a row. The odds of that is 1 in, it's 1, 3, 8, and lots and lots of zeros. That's actually 1 followed by 101 zeros. And that's what in mathematics you would call more than a Google, which is where you got the phrase Google, where Google got the word Google. It's just an incredibly large number with 100 zeros. This is actually larger. And the real Google is spelled Googol. This is Google changed the spelling because they appropriated the number. So that's pretty. The chance of this being just random is just almost impossible. But there could be some natural variability in cycles. But if you listen to some politicians, including some in your state here, or read some places, you'll see global warming stopped 16 years ago, or sorry, global warming alarms, the Earth is cooling. These are real headlines from within the last year. So let's take a look. This is from figures I downloaded from Deke's office. This is the global average is 57 degrees Fahrenheit. In the 1950s, the decade was slightly below 57, slightly above in the 60s, slightly more above in the 70s, the 80s, the 90s. You can take a look at this. And 2010 through 2012 is just slightly warmer than the 2000s. Each of the decades has been slightly warmer than the decade before. So, and then let's go to the next one. But what about, actually I forgot. Can you go one more? I think I got it out of order. Yeah, there we go. I put them out of order, sorry. The top 10 hottest years on record, you'll see 2010, 2005, 1998, 2003, 2002, 2006, 2009, 2007, 2004, 2012. This is also courtesy of NCDC. So if someone could explain to me how the global warming has been on pause for the last 16 years when all the top 10 hottest years on record have been in the last 16 years, I don't quite understand that. It must be some magic, anti-reality numbers these people use. So, all right, let's go backward. NOAA has looked at climate change attribution, which is another, how do we know this is man-made and not natural? They looked at, they used all these different ways. And this is how a science reporter, I want to look for some evidence, and I want someone to show me that this is not, they're just not talking out of their rear orifice here. So it's 4 land surface, air temperature, 6 sea level, 7 ocean, and 3. These are all these different ways, and I think if you add them up, it's well over 30. Let's go a couple more, skip 2 more. So now we know this. So what happens when you tell people, when you write, basically show the science? You get attacked. This is climate change skeptics have done this, and the next one, and that. You can find those on the web. Trust me, I have. So what does all this have to do with water? National Climate Assessment, which came out earlier this year. Some extreme weather and climate events have increased in recent decades. There is new and stronger evidence that many of these increases are related to human activities. Changes in extreme events are the primary way in which most people experience climate change. Human-induced climate change has already increased the frequency and intensity of some extremes. Over the last 50 years, much of the U.S. has seen an increase in prolonged stretches of excessively high temperatures, more heavy downpours, and in some places, and of course, skipped off this, and in some places, drought. Let's go to the next. Saw this map already, so a lot of reporters have stopped at this map. You want to go one more, let's go to the next one, and let's look at the figures. Yeah, as the report showed you, the word none is, they're actually not dry, which is kind of an odd thing to think about. D0 is abnormally dry, but not a drought. D1 is an actual drought. D2 is severe. Then you go exceptional, and then D4 is what I like to think is, oh my God, drought. So right now, 5% of the lower 48 is in an oh my God drought, and 1 year ago was 2.5%. That's about double. Take a look at 2, 3, 2, 4. The 2 worst extremes, it's 17%, basically more than a sixth of the lower 48 are in this extreme drought. It used to be 7%. Again, more than double. And you see the same thing for the three worst droughts. It's not quite double there, but you see that it's worse than a year ago. But it's not as bad as 3 months ago, so that's one way to look at it. All right, let's go to the next one. So how do here's one of the stories one of my colleagues here wrote, that the USDA has designated that 76 of Oklahoma's 77 counties, and nearly 2/3 of Arkansas counties, are primary natural disasters due to ongoing drought conditions. All right, next one. Of course, the picture tells it better, and let's go one more. So when you're dealing with this, you're looking at three worlds as a reporter. These are three intersections of three worlds. There's the world of scientists like Deke, and the world of climate science, and then the world of journalists like me. So let's see how they interact. In the world of science, essentially these are people who are driven by data, not anecdotes. They're objective, sort of a cool medium instead of a hot medium. They deal with incremental stuff. They write lengthy journal articles. The National Climate Assessment, I think, is around 16 to 18 megabytes if you download it. At least on my computer, it gums things up for quite a bit of time. And they take forever to write these things, Only a year or two ago were they finally concluding that the 2003 heat wave in France could be attributed to climate change. It took them about 7 to 8 years. Let's go to the next. So if you look at the world of science as a Venn diagram, theoreticians at one end, experimentalists in the middle, and then science communicators, like Deke, who does a good job of science communicating. Then the subcategory in there is climate. So you have, at the top, you have climate averages. That's how for 20, 30 years climate scientists were doing. They were dealing in means and averages. And boy, the temperature is now a tenth of a degree warmer in this decade than it was in the last decade. I'm sorry, I don't know about you. I never felt average. I either feel good or bad. You don't feel the temperature. You still go outside and say, gee, it feels average today. It's not what you notice. What you notice is at the very bottom, the climate extremes, when there are hurricanes, blizzards, tornadoes, heat waves, cold snaps, downpours. This is what you... Unfortunately, when it deals with water, water's sort of in the middle because, as Deke showed, droughts are so incremental. They happen slowly. Now, downpours are noticeable, but droughts happen so slowly that it's not as noticeable as climate extremes. Now, Mother Nature has caught up with climate science and dragged them into realizing that the real thing to talk about are these extremes. It's what affects people more. It's what affects species more. When species move, when they migrate earlier, when they move north or up in elevation, which they do, it's usually right after an extreme event. All right, next one. And so now here's my world, the world of journalists, and I know some of you are hoping to join. I don't know why. We like anecdotes better than data. We have the anecdotal lead. You don't have a data lead. If you've never heard of a data lead, I certainly have wanted to try them, but I don't think that happens. We're much more subjective. In Mike's world, of television, you often hear the "how do you feel" question. So it's a hot, not a cool medium. We like, drama is what we're all about. We're not about incremental stuff. You have to have something dramatic there. We write brief. I write usually 600-word stories. I'm lucky if I can write a 1,000-word story. And fast, I have to write it yesterday. So now let's see so the world of journalists, let's put it at the top because I'm there, so I like to be at the top there. Science writers, technical writers, medical writers, people who do a good amount of explaining. Then you have general assignment reporters who just parachute wherever they go. Politics reporters, television morning show reporters who it's all about them. Sports reporters, celebrity journalists at the bottom. All right, we put them all together and I don't make a good Venn diagram, but something like this. And what in that intersection that you don't really can't see are the climate extremes, the heat waves, the storms, science writers like me, good science communicators like Deke, and the letter B because it just fell in there. I don't know how it got in there and I forgot to get it out. So what's not in this intersection? Most television media, not the political reporters, not the most politicians. In politics reporters, they do this he said, she said, false balance. I don't know if you've heard of that. There is no false. There is no other side to gravity. There is no other side to the world is round. And if you talk to scientists, there is not much of another side to climate change. And most importantly for this issue, this session, it's water issues. Don't quite fit in because, as Deep explained, water is not sexy. So it's incremental. It happens slowly. It doesn't work well on television until you get to the very end. And then the question that news editors and broadcast managers are going to ask you, why do it today with a drought? How is today different than yesterday or tomorrow? The news hook is so much harder because it's so incremental. So let's go next. And we, of course, take it for granted. Think of your last meal in your garden. Fountains of Las Vegas. Golf courses. As you heard from Deke and Baxter, water is just, it is life. No water, no life. There really is no other way to say it. Water is life. Let's go to the next one. So, for those of you who are reporters, how do you deal with this? I actually am a science writer solely because of a drought in 1989 in South Florida. I was a government and politics reporter. Drought happened, and I was the one who was asked to cover it. The environment writer was too busy, and I'm very thankful for that. The drought got worse. I essentially wrote nothing but drought for a long time, and then weather, and then hurricanes, and Hurricane Andrew struck us. And then from there, I was hooked on science and environment writing, and I've never looked back. But back then, I found some really interesting stories in a drought that sometimes you have to think a little differently to get. Here, check the water bills of government agencies and of the government water managers like Baxter. He's telling us right now that we should be, using less water. So the question is, if we looked at your water bill, are you using less water? And so, to me, that's a... Oh, okay. Well, then you can't tell because you're off the water grid, essentially. But that's also good because you're using a rain barrel. If you're off the grid, you're not sucking at the same reservoir that the rest of us. But when I did this, my colleague Mike Saunders and I did this story 23 years ago now. South Florida Water Management District had put severe restrictions on us. And so Florida has a wonderful sunshine law, probably one of the best in the nation. We could look at people's water bills, and we found that of the 5 water managers who, from public water supplies, in other words, not water barrels, 3 of them did not cut back. 3 out of 5 actually used more water, and the district's top executive used about 4% more water in January than in December. Now, sure, you're going to use a little more in general, more water in January than December. Well, it all depends on your own personal circumstance. And he's talking about his college-age children came home and took long, long showers. Those would be very long showers, but they were shamed. And it is one thing if you're going to ask someone to cut back and not do it yourself. So as reporters, I always suggest check the water bills. Check the water bills of the agencies too. The federal agencies, federal government, and local government back there also use more water. Let's go to the next one. I did, like you guys here, spent a lot of time doing a larger story. Day or two before the larger story, 2-3 inches of rain fell in one day. Editors wanted to just kill the story, and I convinced them that this is not really a cure. It is a one-time thing. So we ended up writing the story, and we called it "Dry Despite Deluge." And in a way, it was a better educational message because it was reminding people that it's just not over with one big rainstorm. But the other lesson to be learned is if you've got something ready, get it out now because it's going to rain and ruin it for you if you hold it. And then you bring this home. Bring it home to people because it's how people water use. This is the demand part of what Deep talked about. We convinced the family to let us spend a week with them, more or less, watching their water use. We monitored, we looked at their monitors, sometimes hourly. We measured how they used water, measured, the showers, measured the toilets, measured drinking water use. The father put on a bathing suit when when he showered, and we went in the shower with him, took pictures, and measured how long he was taking a shower. This is the type of thing that's actually very useful for people, because people don't think about how much they use around the house, and this helps. So, and I think that's it for me. So,
thank you. Well, we've got a lot to think about. We've got time for a few questions. If anybody would like to ask a question or comment, please feel free. Yes.
This is for Dr. Review. You talked a lot about.
Can you give me the microphone? Hold on just a second.
Can we do the mic?
Yeah.
You talked in your presentation about having a push for building infrastructure to help move water, I believe. What do you think, in areas of Oklahoma specifically, where should that focus be? Is it in certain sections of the state, a particular type of infrastructure that we should be trying to build?
Yes, okay, thank you. That's a good question. Well, I showed a map there, and there are a number of sites. Actually, it's a surprising number of sites across the state. But basically, you have to have precipitation. You have to have conditions that promote runoff. So soils that generate less runoff are typically clayey soils. And you need an aquifer if you're going to do recharge. And so there's also some recharge sites located on that same map. So really there is opportunity to build a number of different reservoirs. One that is being looked at right now as a potential are some reservoir sites in southeast Oklahoma that could be utilized. But of course there's issues of water rights, and then the planning and design of these are no small task. They cost a lot of money. And the horizon, it's not going to be a solution that is going to happen next year. But we have to think ahead, particularly with the prospects of climate change. If the drought conditions do continue, then we're going to need that extra capacity. What can we do in the meantime? Well, there's water reuse opportunities, which is, I don't know if you get what that means, but that's treated wastewater. We discharge about 20 million gallons a day on a dry day down the river from Norman. And once it's in the South Canadian, it becomes too salty to easily use, and so it could be treated and then reintroduced into our drinking water supply. But that would also require some permissions from the Department of Environmental Quality to permit us to do that. So there's sort of the complex web of regulatory requirements, planning and design horizons that affect our ability to make very agile or quick decisions. But they have to be made. Otherwise, we're simply not going to be able to withstand the droughts of the future.
Actually, I have a question for you guys from this. My question is, you talked about some 50 to 60 reservoirs that could be built.
That's right.
And if I were an Oklahoma resident, I'd go, my gosh, this is not the first drought. You know, you look at the state's history and how drought-oriented its history is, and you look, obviously the Dust Bowl in the 50s. So why, after two amazingly large droughts that you illustrated, did no one create more reservoirs? This is not a surprise. Droughts happen in Oklahoma. Why aren't there more reservoirs?
It's a good question. Part of it has to do with politics, and people come out against reservoirs from environmental considerations, or there may be people who claim to have rights to water that other people don't. There's always resistance to transferring water from one region of the state to the next, let alone across the states. There's, of course, interest in buying water, Texas buying water from Oklahoma. And we waste water every day. We discharge the Red River. It becomes too salty once it's in the river to be easily used. For some price, it could be treated. But so it's a matter of distribution, not really availability. And distribution meaning having the infrastructure in place to do it. There was a great forethought in our previous leaders. Senator Kerr developed a waterway, the Kerr-McClellan waterway, so we have a Port Catoosa in the state. There's a huge investment in water resource infrastructure in the 50s and 60s. But a lot of that has gone away, particularly in the 70s with Jimmy Carter. A lot of it's just impossible to build more dams. And there are environmental concerns, legitimate ones. Perhaps they could be overcome. And we could actually build more reservoirs. I don't know. That's an open question. And so I think there are a lot of competing concerns that also dissuade people from making hard choices. And maybe earlier on it was less expensive, and there's a political will to actually do it. I think it's got away.
I'd like to add one, too, if there's no one from the floor. I want to ask, what might be, for example, an average amount of water use in a residential home per day, and how might that, do we need to be thinking about cutting 10% of our water use, 20% of our water use? I mean, if we were to sustain at the current levels, you said we'd be out of water in Lake Thunderbird in 2 years, how might we stabilize that condition given what the drought has been?
We can only prolong the agony. We can't conserve our way out of that. Now, if you suspended all use of water for any other purpose than drinking or consumption, then I think we could. But that would mean no car washes, no lawn watering, no other industrial use of water. And, are people willing to make those hard choices? I think sometimes, believe it or not, people aren't willing to do that. And so, but you really, I don't think you can conserve your way out of the drought. You can reduce its impact and lessen it. In fact, we are, the water restrictions have been implemented by the city of Norman. So we are conserving water right now. And so it's a small amount. This is not our high use season, but it's a good start. And as we go into the summer season, if the drought continues and we still need to have those water rationing restrictions, then we will wish that we had started even earlier. So it's a good thing that we started even though it's a low use period.
Technically, the answer to your question is about 80 to 100 gallons per person per day is the average water use according to the U.S. Geological Survey. But the big question is when you listen, Hector, you talk mostly not about it, what it is. It's about choices. It's more societal choices than anything here. While you talk about people don't want to give up their green lawns. Green lawns are not natural in Oklahoma. They're not natural in Las Vegas. They're not natural in much of this area. They require excess water. So this is a societal choice. They weren't natural in Florida either. This is an artifact brought over from England years ago.
Yes.
And so, but it is a giant water-sucking choice.
Exactly, and I completely agree. So it is a societal choice, and oftentimes people, if they aren't willing to make those hard choices, it's also hard to convince the legislature or some other funding entity to give them money to solve water problems if they haven't made the first choice themselves, like I say, conserving their own water. So there's a lot of opportunity for xeriscaping, for low impact development. And we haven't really done that here in Oklahoma. The other thing that's a bit baffling too is that we have a warm season grass called Bermuda grass. It naturally goes brown in the summer because of when it gets droughty or very high temperatures. And people think, oh my gosh, my lawn is dying. They water it. And maybe that's not familiar with the natural cycle that the vegetation has. And so you see people trying to bring their grasses back in 100-degree temperatures when it's just gone dormant for the summer or for that period by watering it. So it's a huge waste. And okay, I have it xeriscaped. I have taken out the lawn areas and converted it more to rock gardens. I'm not completely there. I'm getting there, okay? But it is a societal choice, and I think that needs to be addressed just as well before we can make for a new reservoir site in southeast Oklahoma and to build a pipeline here to put it into Lake Thunderbird, you're talking maybe $300, $400, $500 million. just put a value on it. And so that's not an easy decision to make, particularly if, say, just the city of Norman wants to do that, or a group of communities in central Oklahoma. They can band together and do it as a partnership. But it's a significant expense.
And Keith, can I ask you a question here? In general, nationally, how does the drought of last year compare to the 50s, to the Dust Bowl and other droughts? I mean, are we number 1, number 2, number 3, number 13? How are we in comparison? I know they're all different metrics. Is there a general way to look at it?
Sure. So when we compare into deep district like that, we usually do a drought tool called Palmer. So several Palmer measures indicate that this drought is as large or slightly larger than what we experienced in the 50s. That's at its peak in summer of 2012. So basically comparable to the 50s in terms of its size. There's 3 ways to measure drought. The size, the actual size of the footprint, the intensity, how intense are the drought conditions within that footprint, and the duration. And so for magnitude, for size, we've tied basically the 50s. It's slightly larger, but it's basically tied with the 50s. Not quite as big or as intense as some of the expansions that we saw during the 30s, and not on par with the 50s yet in terms of duration, or the 30s. So it looks as bad as a snapshot as what we saw in the 50s. In fact, it looks slightly worse when we snapped it at its peak in the summer of 2012. But the duration isn't there. Those were 3, 4, 5-year events that had ebbs and flows within them. But it characterized a decade. And we haven't characterized a decade yet with this drought.
But that's a part of it is because we're not over yet either. Right? We're looking from the middle, or we might be near the end, but we're still ongoing, so we don't know how long this lasts, right?
Yes, and we are still in that, drought is like any other kind of pseudo-living phenomenon, and it kind of mutates and evolves as it carries on. And we've seen real westward and northward creep of this particular episode. So, one thing that's not really germane to Oklahoma is the lack of snowpack in the west. You can get away with that for 1 year using the reservoir system. We're entering a second winter with really low snowpack in much of the west. And so even if the drought isn't as severe, even if it doesn't light all the lights on the intensity scale, that second straight year without snow melting into reservoirs we're going to be hearing from tens of millions of more people about water issues in the west, unless we get snow on the mountains really quickly.
And there's no real forecast for snow in the mountains real quickly in the next month.
Doesn't look real optimistic, no.
And so, in general, is there one way, by the way, have you all looked at taking those 3 metrics, and sort of combining them or multiplying them in a way so you have one metric that takes length and duration, intensity, and breadth, and multiply the 3, come up with one number? Is there anyone who does that?
The best approximation to that is the Drought Monitor, which comes out weekly, and part of the guiding principles of that effort is to try to simplify the billion different drought metrics that we have into one. So they do consider things like short-term versus long-term. They do consider things like seasonality, but there's no real drought index, national drought, number where we've combined these 3 facets. And if you have ideas about that, I'd love to talk with you about it.
But the drought map that we just saw, and you've shown and I've shown, that only goes back, the statistics only go back, about 5-7 years or something like that?
Goes back to 2000.
Yeah. So it's not really good for historical perspective. So just, not to put you on the spot, but I always like to do that.
Okay.
You've seen your colleagues at the National Center on Environmental Prediction's Spring Outlook.
Mm-hmm.
You know what is happening, both large scale with climate change and smaller scale with local with moisture index, and then with El Nino and La Nina and other oscillations. If we were having this talk a year from now, better or worse?
I don't know about better or worse, but drought will be a big issue during 2013. I'd be stunned if it wasn't. I don't do well with prediction, and I honestly haven't looked in the last few weeks at the predictions, but it's going to be a big issue. Right now, the West, especially the far western U.S., is past their big precipitation producing season. They're in the they're in the end of the fourth quarter as far as water supply goes. So then the attention focuses to the plains in the Midwest, where April and May and June are really, that's the playoffs of water supply. So while the plains still has statistically their best chance to get out of trouble, much of the West has seen that go by. So 2013, like 2012, is going, I'd be surprised if it wasn't characterized as a year of drought.
Okay. Last question, please.
We've all heard of El Niños and La Niñas. Just in general for the United States, I know that it's even different in different regions of the U.S. Which of those oscillations, an El Niño, which is the warming of the Central Pacific, and the La Niña, which is the cooling, which of those is more conducive to drought breaking, and which is more conducive to drought triggering? Where are we now, and what are we heading into?
So a rule of thumb, kind of with a 2 out of 3 kind of level, 3 out of 4 level of success, is for most parts of the U.S. for most seasons, La Nina is typically drier. The episode that we saw in Texas and Oklahoma in 2011, northern Mexico, that was a pretty classic La Nina signal and a pretty classic La Nina look and feel to drought onset. The West is a little different. El Nino, for most of the U.S., kind of the southern and eastern 2/3 of the U.S., El Nino is usually better news in terms of bringing water. There's, again, regional differences. And right now we're right in the middle. Can't make up its mind. We're in neutral conditions, or what some people call La Nada. So neither El Nino or La Nina.
And we started into an El Nino and then sort of stopped, right?
It kind of petered out, yeah. So we look to be in these neutral conditions for, I believe the Climate Prediction Center is saying spring, the Northern Hemisphere spring.
Okay. What that all adds up to is a great deal of uncertainty, but certainly a need for greater awareness and conservation. I'd like to thank our panelists here today, Deke Arndt, climatologist, Dr. Baxter View, a hydrologist, and of course a well-respected environmental and science writer, Seth Borenstein. And thank you very much for attending the session this morning. Again, I bring your attention to our student reporting from the Gaylord College on the Special Water Project in the Drought, which can be found at roots, ROUTES.OU.edu over the period of the next 6 weeks or so, and on Twitter at #watercrisis. Thank you all. Let's thank our guests, please.